Thank you, Francis. Thank you so much. Glad to be here today to tell you about one of the projects I'm about to get involved with an In-Situ group of companies. And I'm going to talk about best reclamation practices in the In-Situ. And the reason I put construction in the title, because construction is very important. We tend to overlook construction, but how you construct your site will influence your revegetation success in the future. So that's why I want to talk about construction is a very important component in the practice of revegetation. What is In-Situ? I think all of you pretty well know what is In-Situ oil sands. And In-Situ is basically like underground bitumen mining, because the bitumen is too deep into the ground, so we have to go with steam and trying to extract it out compared to open pit mining. And when you talk about mineable, about oil sands research and reclamation, most people are familiar with a bigger mineable oil sands like Syncrude, Sunco, the type of work we are doing. But the In-Situ tend to fly under the radar a little bit quiet, and not much is being known, I think, about them, what we are doing. So within the In-Situ, it's what are the challenges? With open pit, is huge acres being affected, and of course we have to reclaim them. But nevertheless, with the In-Situ, when you talk about disturbances, it's quite a contentious issue. And how do we reclaim them? Because we have the In-Situ consists of well heads to extract the bitumen. Oops, sorry. You have many of those individual wells. You have access roads in order to gain access to those wells. So when you pull all that disturbances together, it becomes quite a huge impact on the landscape. Lots of fragmentation with linear disturbances, and of course it affects wildlife and so on. And the goal is how do we construct that in a faster way so that we try to reclaim the disturbances and have less of an impact on the ecosystem. But the challenge, like I said, we have so many well sites with the fragmentation. We have varied topography within the sites. And we have lots of plant materials and so on. We have to try to, of course, lots of them go to the mill for timber, but many times, many circumstances, not all of them go through, and lots of them are being wasted, and some of them have to be burned and so on. So how do we make the best use of those woody material, and how does those impact reclamation? So this is what I want to touch on today. So, like I said, disturbances is quite a contentious issue in the oil sands, and minimizing disturbances is very important in any reclamation project. You want to avoid wherever you can, try to keep your disturbances to a minimum, but in many cases it's not possible. It's not possible because of a constraint of safety and wherever sites are and so on. So disturbances is part of doing business. But then the question is, how can we more effectively reclaim it so that we can accelerate reclamation and get the ecosystem back on the right trajectory? So the geology of a landscape and the constraint and so on will dictate the size of a well pad. In many cases, the well pad here is about like 80 meters, could be anything from 60 to 100 meters. It varied based on where it's located and so on. But nevertheless, when you have thousands of sites within a particular ecosystem, it becomes quite challenging to reclaim. And in many cases, when one of a particular well site, will go through will be located through 2 or 3 eco sites. So when you try to reclaim that, it's not just a matter of putting dirt, put a terrestrial ecosystem, but you try to rebuild that 2 or 3 ecosystem that exist right there. It could be like aspen, black spruce, tamarack ecosite. So you have to try to reconstruct these ecosites, the landscape, the soils and so on, put them in a similar fashion to be able to support the different species. So you have about 2-3 ecosites within each site you got to restore. So that becomes quite challenging at times. And also you have the water regime you got to restore also. The water flow is very important. If you don't have a proper water flow, you won't have a type of species for it to support. So it's not only a planting game. The reason because like everybody thought like, oh, well, we got that size, we put in the soils there, we just go put a few stems into the ground, we walk away, it's done. It's not. It's more than that because natural regeneration is always encouraged because many of those sites are disturbed. Like on each of the permit, you will have a couple of hundred sites that are disturbed within the same year. And the vegetation, the dirt, everything is put back within the same year. So in many of the sites, like where natural regeneration is slow, you have to go and plant and put some stems into the ground. Like for example, like in this case, it's a white pine, it's a pine tree. But in many cases where natural regeneration doesn't happen, you have to go and plant. And it's not a matter of just putting a few aspen and white spruce and walk away. What we want to do to be able to restore the ecological integrity of a site, of a function, so that it can support the different values of those sites. And that's one of the goals identified by OSLI. In sometimes around 2009 or so, OSLI started this project, trying to look at faster forests, trying to see how we can speed up reclamation in those sites, because many of those sites are disturbed within the year. The vegetation, everything is put back within the year. How can we speed up the reclamation so that we can reduce the fragmentation, get animals to come back to the site, make use of those habitats again? So we're trying to look more at the ecological integrity and the function of the sites. We have to restore the hydrology also. So that's why I said it's not only about planting a few trees and walk away from the sites. So that program started about 2009. And in 2010, we started to put a few plants there. And again in 2011 and 2012. But right now, we don't have any monitoring on those sites. We're going to start that pretty soon. And what I'm going to do, talk about what has been doing so far in terms of woody debris management on those sites, trying to restore those sites, and some of the planting that has been occurring on those sites in order to speed up reclamation. And then the next phase towards the end, I will talk, maybe just mention the program we're going to undertake in 2013 to look at gathering some of the practices, doing documentation and so on to make it available to the industry. And also then to follow through the monitoring program. So in 2009, we were only planting like about one species, like aspen mostly. About 30,000 stems was planted at that time. There was little disturbances. And by 2010, we start to improve. When I said we, I mean the OSLI group of companies, like Synovus, Statoil, and ConocoPhillips, and so on. We start to increase the number of species, like from one type of species to more of a jack pine, white spruce, balsam poplar, and so on and so forth. And the reason for that, because like I said, we have about 2 or 3 ecosites within a site. And not only planting one particular species, we want to be able to restore the different ecosites. So we have to increase the number of species. And then in 2011 and 2012, we also look at many of the shrubs, the different shrubs within the different topography. And this has been increased also. So construction, best management practices is very important about construction. Most of the construction, pretty well all of the construction happen in the winter because of access. You have to be able to access those sites. And the only time you can access them is throughout winter when the ground is frozen. And also it's done in the winter to keep disturbances to a minimum so that you have less compaction, less vegetation, and so on. So, and I will emphasize that the key to reclamation success lies within construction, because how you put back your dirt, how much organic material, plant debris you save, you try to bring those back. Your branches contain propagules, your tree stumps contains microbial, like mycorrhizae, microbial organism, and so on. When you bring that back to the site again, those play an important role in influencing the revegetation success. For example, like in this site, when you talk about construction again, we have to create the different microsites to facilitate planting. And we hear before that rough is good, rough topography is really good, because rough prevent erosion, help to capture snow. At the same time, it creates those microhabitat for those plants to be able to survive, because moisture is always important. And so that's why it doesn't have to be nice, polished like your typical farmland, but you have it such in a rough, try to mimic as much the natural surrounding The nice, gentle contour is very important. It's not like just push the dirt, put it there, plant your trees, and walk away. You try as much as possible to create that micro-topography within the site. So that's why you see lots of tree stumps and little sticks that are being planted and so on. So same again, like when you try to build a site, you have to make the contour fits within the ecosystem. Because this is very important, because there's the hydrology on the side, the low ground areas that support the water movement and so on. Very important to restore those activities. And if you cannot restore that, then you won't be able to support the different type of plant communities you want to support. I don't have any hard data for you guys. All I have is just pictures to show you. And pictures is easier to digest given that it's Easter. So next time when I speak, I will have more data. But typically when you have a site like being constructed, all the stuff are pulled, the tree stump, like all the good wood are taken to the mill, and whatever can be salvaged or salvaged for different function. But the rest of them are being stockpiled, and later these will be burned or be put back on the ground. How much to burn, how much we need for reclamation, this is always an issue. Sometimes companies pile them too much, and decide, hey, you know what, we'll just burn them and get rid of them, that's it. But it's very important to have all those lumps and so on returned back to the site, because it does help towards creating those microsites. And for example, like this one, when the ground is clear, they put a little bit of root materials here, a little bit of stems here and there, but this is not enough. You could have used way, way much more. And many of the slash, it's all put here. And these, like either the companies, the contractors will decide, hey, you know what, we'll burn them. But that's not a good practice, because many of those contain microorganisms, mycorrhizae, plant propagules, and so on, that are beneficial in reclamation. So the best idea is to bring those back. A site like this one could use more of those debris. And the coarser they are, the better. Like, people talk about mulches. Mulches is good, but if you have it too thick, it keeps the soils cool, prevent it from warming up. It controls your weeds also, but at the same time, it prevents natural regeneration from occurring. So mulch is not good. Coarser material is better, because it allows the plant materials and so on to grow. So much of those materials can be put back here and then plant afterwards. So again, rough mulching or chunk is preferred. And the coarser the material it is, the more ecological benefit it is. So rather than just burning, like try to get maximum onto your site, and then whatever is left, you can just leave it there, or then you can burn or whatever. But the more material it is on this site is really good, because they create those microhabitat that will help your site to regenerate faster. And by having plant propagules and coarser materials, preserve as much as you can. This is what happens. You get those materials in the spring trying to green up again. So many of the sites doesn't have to be planted, but it will depend from the sites to sites what practices has been done. And based on the outcomes, like then we'll decide, if the sites need to be planted or not. Right now, with the Faster Forest program, many of the sites have been planted, but many of the sites have been left also to natural regeneration. So we don't know the benefit, whether it's good to just leave everything to natural regeneration, or how much do we have to plant. So hopefully in the subsequent coming years, we'll try to find out, how much planting do we need to do, how far do we go. For example, like this site, it's lots of those woody debris has been burned. And in this case, it's not too good, because this is like an upland site and subject to erosion from water, both wind and not much propagules. So a site like that will take way, way longer time to recover. So definitely, it has to be planted with, and then take a longer time. Yet, if you have preserved your woody material, like your coarse woody debris, your wood, your roots, and so on, and put those back, you will have much faster success in regeneration. For example, this is another site where much of a slash, again, it helps suckering to occur from the root material and so on. And what this does, it prevent, it helps to stabilize the site, facilitate growth to occur, and also we haven't looked into the role of wildlife. For example, if you have like many of those locations of caribous and so on, like if it's easy access, if you have vegetation way faster, you have coarse woody materials and so on, guess what? Then other predators cannot run as fast. So this way we provide protection. So this is something we have to look into the future, but right now, coarse woody debris is pretty good in terms of trying to get a site on the right path. And also like this one where you see like you have coarse woody debris where you have like lots of natural regrowth occurring from the woody materials we try to salvage. So it's very important to salvage as much woody materials, the roots, the propagules, and so on, and put them back. We do speed up reclamation. And we try not to blanket as much with mulch because if we do that, it tries to impede reclamation. And we avoid strip size. We try to spread it evenly as much as we can rather than just try to put them in strips. We try not to do that. But basically, the mulch will be like, like if you have to put the mulch, don't put it too thick, like maybe 5 centimeters good. But if you go deeper, like, 10, 20 centimeters of mulch, then you try to stop growth from occurring, from natural regeneration. So that's why we said, like, use coarser materials. That's better than trying to mulch them. You spend all that energy into mulching and then spreading and so on. So your coarse woody debris is way preferred. And I think Matthew will agree with me. He's looking at me. But anyway, and why do we have to plant sites? Why not? But there are times that we have to plant sites. Like for example, if you leave a site, if a site is too close to a roadway, like a major roadway and so on, and many of those roadways have been seeded before. We have we have grasses like brome grass and so on occurring, and guess what? This is what happened within a year. You will have growth, and then you will have a difficult time of getting trees to get established. So that's why in many cases, if a site is close to a roadway and so on, guess what? We have to go very really fast and try to get vegetation established. Because once you get your vegetation established, you try to get the grass from getting established. Because those grass don't like shade. So your trees and so on will give you like the cover, which those grass won't like. So this is again like how many plants do you have to put? Like sometimes, like the regeneration standard is about 2,000 stems per hectare and so on. But in this case, I think we put about like anything about 1,800 or so. But in the future, because many of the sites you're planting also have natural regeneration, you may have to reduce the number of stems you're planting. But that's a site-to-site basis. The contractor has to make that call as to how many stems are we going to plant. In this case, you could see how close we are planted. And the reason for that, because our site is close to the roadway, and you get a major ingress of grasses, like over grasses occurring, like those are reed grasses occurring. So if you don't plant quite a thick density of plants, then the grasses will tend to take over. So you try to increase the number of stems just to outcompete the grasses from getting established. So those are like, like in the future, we want to be able to go back to those sites and look at the plant growth and see what's happening so that we can use that as future practice. This one again, like snow is good. Like if a site is in a low area, sometimes rather than trying to take more dirt out, we try to use snow trying to level the sites. So this way, it gives fairly nice and flat for equipment to come and do the core hole and so on. So weather plays a very important in terms of what kind of disturbance we're going to have. Like in this case, like if it's a year that we have lots of snow, or we can use water to level the sites, the better it is. So this way, less stripping we have to do. And the problem with that, when the snow and ice get compacted, and many times we forgot, like, just for while spring is coming, the ice is going to melt. But the problem is that the grass is still growing underneath the vegetation. And so what we have to do, we have to go and break that ice surface to let the ice melt faster, get it to breathe, because there's vegetation there, because otherwise, like coming in like middle of summer, you still have a big ice cap. You want to break that as fast, get the vegetation to grow. So those are some of the practices that have been happening, like, try to use like snow or water to an advantage. This way you have less to strip, you use that to level your site. this is what we call boutique planting. Andrew Carpenter is one of my colleague working with us on the project. He tried to look into the different collections, bringing in the plants and planting. But it's not we call it boutique planting. It's not planting like one or two different kind of species. We're looking at a number of shrubs, like from blueberry, from some of the sedges, mountain havens, like quite a variety, like equisetum, which is horsetail. We're trying to look at a number of species that can be used to effectively stabilize the site and get that speed recovery. So we call boutique planting because now we have a choice. We're not looking only at 3 or 4 species. We're looking at like maybe 15 or more species, from trees to shrubs, anything you can do to accelerate the reclamation recovery. So that's a term Andrew tried to use, boutique planting, so thanks to him. And this one, what you see, just like you look at a site, like you may have one particular group of species here, you have a mix of species here, you got more deciduous here. What you're trying to do, like by having a choice of species, you're trying to replicate that ecosite. Like within a site, you have 2 to 3 ecosites. You're trying to have a number of species, trying to replicate that as fast as you can. And I think in this case, we have green alder. We're also planting lots of green alder. And again, like plant performance will vary from within a site, because the site has the higher end, the middle, the low, and always you have better survival on the low areas because of the amount of moisture. In this case, for example, you have little pine trees. On the higher areas, it tend to struggle, get dry very fast, whereas the low areas, more wet, you have better success. So there are times that within a site, we have to go back and check on those plants again because they have just been planted like 1 year old or 2 years old. So we have to go back in the future and see how well we are doing or what the challenges we face. Vegetation establishment, again, like when those plants were planted in 2012, like in the old days, when you put a plant into the ground, you're told to really pack it to make sure there's a good contact between the soils and the plant. So this way the plant can have a good success to take on. Nowadays, we talk about loose planting, because the plant roots have to breathe. If you pack it too hard, it cannot breathe. So we notice that plants where you pack it harder, you have less success of the plants taking on. So what we call loose planting now, just leave it fairly loose around the plant, so this way the roots can breathe. So hopefully it has better success. So this is one of the things we are saying, like loose is good now, rough is good, loose is good. And also we look at, you could see the amount of roots now, like, by doing that, like, this is the amount of roots compared, like, the fine roots coming up, all but within a year from the type of planting. So this is really good. The plants look pretty well sort of dormant, like, like maybe dead to some people, but actually underneath it was still growing, lots of good root structure. And one of the symptoms we see in plants, for example, like in this white pine, like it's discolor, like, it's all like sort of reddish, purplish. Is that plant dead, or this is a normal characteristics of the tree seedlings? And we believe, say, normal characteristics, like, this is how we are in the first year, but in the second year we do recover from that. So next year, or this spring or summer when we go in, we'll find out how well the plants are doing. And some of the stuff where Andrew again, one of my colleagues has been trying, is try to look at, for example, like on the sites that are more dry, like the sandy sites up the hill, which are more dry, more subject to less water and so on. What other stuff can we do to have better survival of the plants? So he has been looking at compost tea. So if he put some compost tea where the plants are planted, would that encourage mycorrhizae? With mycorrhizae, will have better success or not? So this is some of the stuff we have tried, he has tried, and some of the white stuff you see on the roots, maybe they are mycorrhizae, we don't know yet, but we'll find out in subsequent years. So construction and reclamation, like they go pretty well in the same year. Like compared to over reclamation, where the salts and so on are stockpiled, and then we go, like, in this one, we try to have everything done within the year. So this way, by doing that, we hope we'll have much better success. And also we do everything possible, like when we recontour the site, trying to have as much natural ingress from adjacent areas. Like if this is an example for a site which was not seeded, but you could see the natural ingress from the big trees is slowly happening, like, within about 3-4 years. Like you can see like the trees and so on. So some sites, not all sites were seeded, some sites were seeded, but those are the stuff we have to look in subsequent years and try to see like what has worked well, what hasn't worked well, and document all that. This one, for example, is a black spruce bog. What happened here, like this site was constructed back again, everything was put back within the same year. And what you can see right here, there's good vegetation, lots of sedges, lots of forbs. There's lots of birch also occurring on the site. And this site, to get a reclamation certificate, usually within the In-Situ, you have a window about 3 years to apply for a reclamation certificate. And to get a reclamation certificate on that is not a problem because you have your major stem and your major species. So that's not an issue. But then if you look at the black spruce and so on, we don't have any black spruce right here. It's not growing. So maybe sites like that, we got to go back. Is it going to ingress over time, or do we have to interfere and plant it? And the problem, because we got a lot of vegetation right here, for seeds to come and land, the seeds have to make that contact with the soil. And given the amount of vegetation from natural regeneration, it's not going to happen because there's no space. So where would that seeds land? So maybe a site like that, although it's perfect, like this site could be certified, but it doesn't have the tamarack and the black spruce we need. Those are the key species for the climax, and it's not there. Does it come back in 10 years, 15 or 100 years? We don't know that. So maybe a site like that, we have to figure out a way, maybe like mounding will be a good option. If you try to create a mound and then plant on top of that mound, so because if you plant right there, guess what? It's going to be choked again. So maybe we have to look at mounding and then plant on top of that mound. So this way you get the black spruce and so on to establish. Because those are important habitat, like habitat for caribou and so on, what you try to create. It's not only about planting, how do you create those habitat to draw in the wildlife and so on. So those are something we're going to look in the future. And again, like planting on mounds, like if you have, this is a jack pine site, which is very sandy, very coarse, very sandy, very dry. And if you don't have enough moisture, guess what? You will have a tough time planting. So in many cases, like, you try to plant on mounds, like in this case, and it may be advantageous, it may not be. For example, in a year that has lots of snow, this is good. This will get an early start because there's lots of moisture. It's on higher ground. It will warm up faster. It will grow faster, put up more roots, go down. But if this was a year what is really dry, guess what? That will dry very fast. So it's a give and take, but what works, we have to sort of take chance sometimes. So this one, again, like time of planting is very important. When do you plant? Because many of those sites, you cannot access them. And so what is the best time? People always like plant when things late in the summer, so this way you have a better chance of survival compared to planting in the spring. Like this one, for example, just in August, first week of August, look at the plants, very nice and green. Third week of August, almost dead. At least the plant looks dead for now. But again, it's a different time of planting. Would that plant still come back next year or this year? We'll find out. But time of planting does have a difference on survival of a species. Like in this case, you could see a much more healthier plant, nice roots and so on, compared to 2 weeks late, almost nothing. So all those will dictate reclamation, like what kind of success we have in the future. And in many cases, in many of those OSC, like oil sand exploration sites, are constructed, put back, reclaimed within the year. But then, except for sites that are in production, you will have a teardrop, and that will stay. But after 10, 15 years or so, when those sites are out of production, you have to go and rip everything apart and then reseed again. So you have to go set everything back again and restart. But now with new technology also the companies are making use of is like this one where we use the water under pressure, about 45 psi. Under pressure, the water goes down the pipe, and we cut the pipe from inside. So it cut from the inside, and then we just use a front-end loader and pull it out. So this is the core hole pipe with a cement casing and so on. And it's amazing that water does that. But we use water under pressure at 45 psi and cut it. And then once they do that, well, they take the well capping, the ERCB number, we just put it down. Like this is what you see right here, the well identification number. We push it down, we cover it up and done. So this is a new technology being tested out there. And in the future, that's one other way to go. And this way, keep the disturbances to a minimum. So we don't have to go back and rip everything apart again and replant. This way, the disturbance will be way, way small. And of course, when you have all the plants already growing, you don't have to rip it. Guess what? You can easily close that slowly. All your propagules, everything will be there. So this is really exciting to see those guys do it. Within half an hour, it's all done. Within half an hour, we just do that, cut out, and then we just have to cover. Really neat. The company's New Wave Technology. We are the one testing that. So with that, like reclamation is very important to the industry, like moving really as a fast pace. We are trying to do the best to reduce that, keep that footprint to a minimum. And hopefully, like this year, we start to go out there and look at the value of a faster forest program, whether comparing sites that has been planted to natural regeneration, and try to see the value based on the forest growth and whether it pays off or not. And hopefully, if we see good benefits, maybe this will determine the best option how to proceed in the future. So that's something new for us. And we still believe that construction is very important to bring the contractors from construction, reclamation all together, because not only moving dirt and then somebody else go and planting. If the construction people understand how reclamation works, this way you have better success in the future because you are going to have a really information exchange. And also, like we have tools, we have a couple of tools already where we have people from SRD, the industry, the contractors, try to get them together all into one room, look at the sites, what has been done, and what are the results. And this way, all the companies can benefit. We don't have to go by trial and error every time. So the information is shared among them. What has worked for me maybe can work also for you. So this is a good information sharing, a good medium to share, make sure we keep that footprint to a minimum, reclaim very fast, and get moving. So in starting this year, we're going to start a monitoring program, trying to go back to those sites again, look at the value between sites that has been left by itself to revegetate and those that has been planted, look at the value of them, and to see the right trajectory and so on. If those sites can be used, for example, like what kind of habitat we're going to provide for the wildlife, whether it's for caribou and things like that. So those are the things we're going to look at in terms of the value this program will bring in terms of reclamation success. With that, I would like to acknowledge the OSLI members of companies like ConocoPhillips, Statoil, Nexen, Synovus, Meg, and things like that. So the whole group companies, and in particular like Terry Forkheim, Terry Osco, and Andrew Carpenter, some of my close colleagues to work with them. So with that, I say thank you very much and look forward to any questions.